All right, good day and welcome to another exciting class. Of course, we are going to be looking at because we are going to be looking at the question above. Now, the question above says draw the shear force and bending moment diagram for a simply supported beam loaded as shown below. Okay, this question, of course, will be our first numerical on a simply supported beam that has what a concentrated load at the midspan. So earlier um, we have proved how to calculate the shear force and the bending moment. So we are going to be treating this numerical even as we proceed. Now, what we are going to be doing is we are going to be calculating the shear force and the bending moment so as to draw the diagram. So the first thing we are going to be doing is we are going to be considering what the upward forces and the downward forces. We know that the sum of upward forces is equals to what? Is equals to the sum of downward forces. Now here we have, of course, this is a support here, so definitely we are going to be having a reaction here, RB. Similarly, we are going to be having a reaction here, RE. So you agree with me that we have two upward forces and one downward forces. So this will be nothing but what? RB plus what? Plus RE equals to what? Equals to what? Equals to 4. So our RB plus RA will be equal to 4. So let's label this as our equation what? Equation 1. So next we are going to be considering taking moment at our point A. If we take moment at point A, it's going to be nothing but what? Our RB multiplied by its perpendicular distance minus what? Minus our 4 kilonewton multiplied by its perpendicular distance also. If we do this, it implies that we have already taken our upward force to be what? To be positive, and our downward force to be negative. So if we take moment at point A, we are going to be having nothing but what? RB multiplied by 4 minus what? 4 multiplied by 2. So our moment at point A, summation of moment at point A equals to 0. We have what? We have RB multiplied by 4 minus what? Minus 4 multiplied by 2. This is what we have. Everything is what? Is equal to what? Is equals to 0. So everything is equal to 0. Now 4 times RB is nothing but 4RB. 4 times 2 is nothing but 8. So this will be nothing but what? 4RB minus what? Minus 8 equal to what? Equal to 0. If I take 8 to this other side, I'm going to be having 4RB to be equals to what? 8. Now if I make RB the subject of the formula, I'm going to be dividing both sides by 4. If I divide both sides by 4, what does it mean? It means that what? Our RB will be equal to what? RB will be equal to 2 kilonewton, because 8 times 8 divided by 4 is nothing but what? 2 kilonewton. So this is our reaction at B. So my RB will be equal to what? 2 kilonewton. So that's my value for RB. So now don't forget that from equation 1, RB plus RA is equals to 4. From 1, RA plus RB is equals to what? Is equals to 4. But we know that RB is equals to 2 kilonewton. So RA plus what? Plus 2 will be equals to what? 4. I take 2 to this other side, I'm going to have RA will be equals to 4 minus 2, which is equals to what? 2 kilonewton. So my RA is equal to what? 2 kilonewton. So that's that for my reactions. So next I'm going to be calculating what? My values for my shear force and then for my bending moment. So I'm going to proceed with my shear force calculation. So for my shear force calculation, we are going to be starting from what? From B. Now at B, we only have what? We only have an upward reaction, which is nothing but what? 2 kilonewton. So my shear force at B will be nothing but what? 2 kilonewton. So F dot F subscript B will be equals to what? 2 kilonewton. So of course for this shear force we are going to be using, using what? Our upward forces are going to be positive, and our downward force we are going to be considering them, taking them to be negative. So this is negative. So take note of that. So what do we do next? We are going to be looking for our shear force at point C. To get our shear force at point C, we are going to be what? Minusing what? The load at point C from what? From what we have here. So it's going to be nothing but what? 2 minus what? Minus 4. Minus 4 due to what? Due to the load acting downward. So our shear force at point C will be equals to 2 minus 4, which is equal to what? Minus 2. This is in kilonewton. So this is our shear force at C. Next is what? It's nothing but our shear force at A. So our shear force at A will be equal to 2 kilonewton minus 4 kilonewton plus 2 kilonewton. Of course, it will be nothing but what? 0. So let's just write that. We have 2 minus 4 minus 2, which is equal to 0 kilonewton. So this is what we have for our shear force calculation. Next, we are going to move in over to our what? Our bending moment. This is take note, this is plus here. So we have 2 plus 2 minus 4. Of course, that is 0. So let's proceed. Our bending moment calculation. So now, for our bending moment, like I explained earlier, our bending moment at B will be nothing but what? Will be nothing but 0. Our bending moment at A, similarly, will be nothing but what? But 0. So all we are just going to be looking for is our bending moment at C. So bending moment at B, like I said, is equals to 0. So our bending moment at C will be equals to what? Equals to the first times the perpendicular distance. So we have 2 here. It will be nothing but what? 2 multiplied by what? Multiplied by 2, because we are considering upward force to be positive and downward force to be what? To be negative. Upward force is positive, downward force is negative. So this is what we have. So we are going to be having nothing but what? 2 multiplied by the distance, which is nothing but 2. So our bending moment here will be nothing but 2 times 2, which is equals to 4 kilonewton meter. So this is what we have. Similarly, our bending moment at A will be nothing but what? Will be nothing but 0. So from this point, we can draw our shear force and our bending moment diagram. So let's do that. So I'm going to be drawing out my lines. I'm going to be tracing this line with a dotted line. So this is what I have. Similarly for here, to have a dotted line traced. And lastly for B, so what do we have next? I'm going to be drawing my reference line for the shear force diagram. Here is going to be 0. Similarly here is going to be 0. So here also I'm going to be drawing my non-negative bending moment. So I have this to be around here. Let this be around here. This is what I have. Okay, so you have this to be 0 and this to be 0. Now anything above is positive and anything below is negative. So let's plot the points. So the first thing we have here is what? At B, our shear force is what? Is 2 kilonewton. So we are just going to be tracing 2 kilonewton upward. So let's take this point as 2 kilonewton. So let's take this point as 2 kilonewton. So I put 2 kilonewton here. So From B to C, of course, there's no load in between, so it's constant. So I'm going to be drawing this all the way even up to C. So this is what we have, even up to point C. It remains constant. Now, my shear force at point C is nothing but minus 2 kilonewton. So I'm going to be going down even up to the negative side by what? By minus 2 kilonewton. So let's take this point as minus 2 kilonewton. This is kilonewton meter. No, this is kilonewton. This is shear force. This is kilonewton. So my shear force at A is nothing but 0. So of course, and there's no load in between. So I'm going to be going with a straight line and taking it up back to 0. So this will be like this. And then taking it up back to 0. So this is what I have. So of course, this is negative, and this is what? This is positive. So this is my shear force diagram for this particular problem. This is our shear force diagram. So next, we are going to be drawing what? The bending moment diagram. Our bending moment at point B is of course 0. Our bending moment at C is nothing but 4 kilonewton meter. So we'll be tracing up to point C, marking a point of 4 kilonewton meter. So let's take this point to be 4 kilonewton. So this is 4 kilonewton. And note, don't forget that for a straight line on the shear force diagram, it is going to be represented by an inclined line on the bending moment diagram. So this is what we have. Good. So we have for this point, we take this point as our 4 kilonewton meter. Excellent. So, and of course, we know that our bending moment at point A is nothing but what? It's nothing but 0. So we are going to be tracing this back even up to what? Even up to 0. So this is what we have. Of course, this too is what? Is positive, and we can as well decide to shade the parts. So this is what we have. So thank you for watching. I hope you understand this numerical that we just solved here. So stay tuned for more and more numerical, even on both simply supported beam and different cases, even as we proceed on what? On shear force and bending moment. So be sure to like, subscribe, and leave a comment if you have any comment on this, on what we have just done here. So thank you for watching, and have a nice day.